Some applications of trigonometry, class 10, exercise 12.1. Seventh problem. From a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building. You should note down that it is above the transmission tower is fixed above the 20-meter high building, or 45 degree and 60 degree respectively. What is that 45 degree? Bottom of the tower, the elevation of the bottom of the tower is 45 degree and the top elevation is 60 degree respectively. Find the height of the tower. So here, from a point on the ground, so let us take this point as, say, that's right, the angle of elevation of the bottom and the top of the transmission tower is right fixed on the top of the 20-meter high building. Let me draw a 20-meter high building first. That's right. Let this be 20-meter high building. And above this, there is a transmission tower. This one is 20-meter height. Yes, right. And then afterwards, it is fixed at the top of high building. This, let this be the tower. Tower height is equal to question mark. Find the height of the tower. Yes, we have to find this height. So, and the bottom is 45 degree from this point. So, the bottom of the tower is here, which is at the 45 degree. The angle of elevation is 45 degree. And the top of the tower is 60 degree. The angle of elevation of the top of the tower is 60 degree. So let me name this as, the top of the tower is A, and this one be B, and this one be C, and this be D. So how to calculate this? You see, this one, the height of the building is mentioned that it is 20 meters. And the angle is here 45 degree. That means this is equal to this one. How can we say that means? For example, we can continue with this problem. Tan theta is equal to opposite by adjacent. That's right. Tan theta, here theta is 45 degree. Tan 45 degree is equal to, what is the opposite here? Opposite is dB. dB, and the adjacent is CB. So tan 45 degree is nothing but 1. What is dB here? That is 20 meter. So what is CB? We have to calculate CB. So upon cross multiplication, we will be getting CB is equal to 20 meter. That's right. This CB, the length of the building from a point on the ground is 20 meter. Now let me move on to find the height of the AB by using this CB. The same trigonometric function holds good here too. That is tan theta is equal to opposite by adjacent. So what happens here? Here the theta changes. That one theta is 60 degree. Tan 60 degree is equal to, opposite is AB. AB by CB. Tan 60 degree is root 3. AB we don't know. What is the height of this whole building plus the tower? We don't know that one. So AB, what is CB? We know that one, that is 20 meter. Upon cross multiplication, we will be getting 20 root 3 meter is equal to AB. Yes, we got this one. So the final thing is to calculate the height of the tower. We know AB, the full total length. And if we subtract the building height from this total length, we will be getting the tower height. Height of the tower is equal to, height of the tower is equal to AD. How to get this AD means we have to take AB, full total length AB minus the building height, that is DB. We will be getting AD. So AD is equal to, what is AB here? 20 root 3 meter minus, what is DB? DB, it is already given that it is equal to 20 meter. It is given. So AD is equal to, if you take the common 20, so what remains is root 3 minus 1 meter. 20 ones are 20 meter. That's all. 20 into root 3, and we have taken meter also common. So AD is the height of the tower. Height of the tower is equal to 20 root 3 minus 1 meter. This completes this problem. Let us move on to the next problem. Eighth problem. A statue 1.6 meter tall stands on the top of a pedestal. So the height of the statue is given here, that is equal to 1.6 meters tall, and it stands on the pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. You should note down that both the tops are given, that is top of the statue is 60 degree, and here top of the pedestal is 45 degree. Is right? You should note down that one. Find the height of the pedestal. We have to calculate the height of the pedestal. Let me draw the ground right now. Okay now? And then afterwards, let me draw a pedestal on which the statue is standing. Is right? Let this be the pedestal, and here comes the statue. Is right? Okay. This one be the pedestal, and let there be a point here somewhere, and the elevation of the top of the statue is 60 degree. Yes, you should note down that it is the elevation of the top of the statue is, this one is 60 degree. Let me write this one as 60 degree. And the elevation of the top of the pedestal, yes, what is the top of the pedestal? Here comes the pedestal top. So the top of the pedestal, the elevation of the top of the pedestal is 45 degree, and what all is given is the height, the statue, that is 1.6 meter. Here the statue, height of the statue is given, that is 1.6 meter. What we have to calculate here is, we have to calculate the height of the pedestal. Height of the pedestal. DESTL, pedestal is equal to, we don't know what we have to calculate here. So let me name this as A, B, C, and once again the top of the pedestal as D. Here, what can we use, which function we can use here means the same, the tan theta. Tan theta is equal to opposite by adjacent. Here I will be taking this small triangle, that is tan 45 degree. Theta is equal to 45 degree. So tan 45 degree is equal to, what is that opposite means? DB. DB by CB. Tan 45 degree is 1 is equal to DB by CB. So upon cross multiplication, we will be getting CB is equal to DB. CB is equal to DB. Yes, let me move on to the triangle ABC. In triangle ABC, tan theta is equal to, once again, opposite by adjacent. So tan theta here is 60 degree. Tan 60 degree is equal to, opposite is AB, adjacent is CB. So tan 60 degree is, you already know, the tan 60 degree is root 3 is equal to AB by CB. So root 3 CB is equal to AB. Let me call this as 1 and this as 2. So next is, what we have to do here is, next we have to calculate the height of the pedestal. height of the pedestal. Height of the pedestal is dB. dB is equal to AB minus AD. So dB is equal to, what is AB? AB is equal to root 3 CB. AB is equal to root 3 CB minus, what is AD? We know that it is given that 1.6 meter. 1.6 meter. And even, let me move on this root 3 CB to the left hand side. That is dB minus root 3 CB is equal to minus 1.6 meter. So what happens here? Here we can change this dB to CB. Yes, right? Now let me change this CB. Yes, right? As CB is equal to dB, we will change this CB to dB. If not, here also you can change. No problem. I will be changing dB. Yes, right? Minus root 3. CB from 1, we will take that it is CB is equal to dB. dB is equal to minus 1.6 meter. So we will take the common dB. So what remains is 1 minus root 3 is equal to minus 1.6 meter. So dB is equal to minus 1.6 meter by 1 minus root 3. Yes, right? In the next step, what I will do means I will be taking minus 1 as common in the denominator. So what happens here? Root 3 minus 1. Minus into plus root 3 is minus root 3 here. Minus into minus is plus 1. Okay now? So minus here cancels. So dB is equal to 1.6 meter by root 3 minus 1. So by rationalizing the denominator, what I will do means root 3 plus 1 into root 3 plus 1. So what happens here? This one will be equal to 1.6 root 3 plus 1, and here root 3 square minus 1 square. How it means? Root 3 minus 1 into root 3 plus 1. So it is of the form a minus b into a plus b, which is equals to a square minus b square. So dB is equal to 1.6 root 3 plus 1 into root 3 plus 1 when divided by a square and root 2 cancel. So what happens? 3 minus 1. So what happens here next is 1.6 into root 3 plus 1. Here also I have skipped meter. Meter when divided by 3 minus 1 is 2. dB is equal to, when 1.6 is divided by 2, you will be getting 0.8 root 3 plus 1 meter. This is your dB, height of the pedestal, is equal to height of the pedestal. This completes this problem. Ninth problem. The angle of elevation of the top of a building from the foot of the tower is 30 degrees. You should read, let us read once again. The angle of elevation of the top of a building from the foot of the tower. That means here building is there and the tower is there. That's right. Let me draw first that one. Let me draw first the tower and the building on the ground. This one be the ground. There is a building here and a tower is also there here. Yes, right. So what happens here? Let this be building and this one be the tower. Elevation of the top of the building. Top of the building here comes here. From the foot of the tower is 30 degrees. From the foot of the tower. This is the foot of the tower. So from here to here, the angle of elevation, yes, right? The angle of elevation is 30 degrees. And the angle of elevation of the top of the tower. Top of the tower means this one. Top of the tower from the foot of the building. From the foot of the building is this one. Yes, right? Foot of the building is 60 degree. Here this is 60 degree. If the tower is 50 meter, the tower is 50 meter. The height of the tower is, it is given that it is 50 meter. Find the height of the building. We have to calculate the height of the building. We have to calculate the height of the building. For this, let me name the top of the building, top of the tower as A, and the bottom of the tower as B, and let this bottom of the building be C, and the top of the building be D. Here too, we will be using the sine function. It will be more easy and more convenient. In triangle ABC, tan theta. So as we know this one, it's easy for us to calculate this is the opposite side. This will be the adjacent side. Yes, right? The ground. The distance between the two foots. Yes, right? Tan theta is equal to opposite by adjacent. Here tan theta is here, as this is opposite 60 degree. Yes, right? 60 degree is equal to opposite is AB. AB by BC. Tan 60 degree is root 3. What is AB? AB is equal to 50 meter by BC. Upon cross multiplication, BC is equal to 50 meter by root 3. Let me take this as 1. So we got BC, the length of BC, that is the difference between the foot of the tower to the foot of the building. We got BC. In next, what we will do means we will try to find using this foot, the distance between the two foots. Let me try to calculate the height of the building. Yes, right? In triangle BCD, tan theta is equal to opposite by adjacent. So what happens here? Tan theta is 30 degree here. Tan 30 degree is equal to, what is opposite? Opposite is CD by BC. So tan 30 degree is 1 by root 3. CD is, as it is, we have to calculate CD, but we know what is BC. BC is 50 meter by root 3. So after cross multiplication, 50 meter by root 3 by root 3, yes, right, by 1, yes, right, is equal to CD. So what happens here? 50 meter by root 3 into 1 by root 3 is equal to CD. What is CD? CD is the height of the building. Yes, right? 50 meter by root 3 into root 3 is 3 is equal to CD. So on dividing this one, 50 when divided by 3, we will be getting 3 ones 3. So 2 is the remainder, 20. 3 is 6 18. So the remainder is 2. So it can be written as 16 2 by 3 meter is equal to CD. Height of the building. Height of the building is, therefore height of the building is 16 2 by 3 meter. This completes this problem.